Coding, programming, software engineering. Many people believe this is the same. Many people believe there's some differences here and there. There's a different philosophy, there's a different perspective for each of those items, depending on the generations, depending on the applications. This is the Hacker's Corner. Hi everybody, welcome back. This is the Hacker's Corner. I want to thank everybody who has been watching us and has been providing a lot of feedback through the channel, through the emails, and for those who send us very nice notes about the show. As you might know, we are running this series of Hack the Border. Hack the Border is an initiative that we have here at EPCC in computing. The whole purpose of this series is to provide adversarial series for the border good, which means that we would like to have this professional development every week. As a matter of fact, every Thursdays from 4 to 5:30 at EPCC Valle Verde. So we provide cybersecurity, artificial intelligence, and software engineering professional developments for the community. And the whole idea here is to train or create awareness to the community about what is really happening in the border and the techniques that we can actually use or tools that we can use in order to solve certain problems. Now we have another piece of Hack the Border, which is the hackathon. The whole idea of the hackathon is to bring the communities from both communities across the border, from El Paso and Ciudad Juarez, and try to solve problems, real world problems that we are actually facing as a community, as a main community between both countries, between both cities. My name is Servín, and I'm very happy to bring you today our guest, Cesar Valenzuela, here. I would like to make an emphasis that I know Cesar for many, many years for different capacities. He's a software engineer here in El Paso, but at the same time, he has an extensive curriculum relating with software engineering. That's how we started this conversation. I mean, coding, programming, maybe it's a software engineering. There is a generation component that moves from one point to another point. And this is the discussion that we're going to have today in Hack the Border. Cesar, welcome to the Hacker's Corner. It's a great pleasure to have you here in the studio. And interestingly speaking, we have Gilbert Ornelas last time, which you will be giving a workshop together with him and other colleagues of yours. And there was a discussion about DevOps, which we will talk about that today, which plays an important role in Hack the Border. And as you know, Hack the Border, we want to emphasize this aspects of computing, including software engineering. So welcome.
Thank you for inviting me, Christian. And yes, a privilege to be here. Gilbert and I, and a couple of the other colleagues that you'll be meeting there, are very thrilled to bring this opportunity to showcase what it is like to be part of this DevOps engineering as it's now trending into the technology environment.
So tell us, thank you. And that's, I'm looking forward, as a matter of fact, a couple of our students who are computer science students and also programming, they're looking forward to attend to your workshop. I think we still have a couple spots for your workshop, but it got filled out like very, very quick. Before we start of everything, Cesar, let us know, tell us a little bit about yourself.
Sure. And I'm thrilled to hear that there's people interested in the workshop. As you mentioned, my name is Cesar Valenzuela. Interestingly, computer science was not in my path of life since I was in elementary. You know how some people get asked, what do you want to be when you want to grow up? A pilot, a police officer. I never said a computer scientist, not once that happened. I actually had my sights on being a professional boxer, which I carried out throughout high school. I was ranked number 3 in the nation, and well, interestingly, I was offered a scholarship.
Actually, when I met you, it was very interesting because I was at UTEP when you were a student there. I was working there as well. When I saw your name, I was like, oh, I know that name. It cannot be my student because this person is a boxer, but it was you.
It was me. It was me.
And then?
Well, one thing led to another, and I said, you know what? Turns out I wanted to join the military, but they said, you know what? You aced math. Don't you want to do something like go be an engineer or something? So I looked at all the engineerings, and yeah, like most people students coming out of high school, I had no idea what I was going to do. I just knew that I was smart and let's do something with life, right? So engineering, looked down the list, computer science. It didn't end with computer engineering, computer science. And I said, I'll be a scientist. And from there on, like life took off. I did the intro to computer science, challenged me a lot, and I wanted more of it. And before you know it, I got out of UTEP with my degree, an internship, and life after that just took off. I got a job at a big missile defense company, and by we I mean like I started with a group of 5 people, and then we started looking into it. We actually did one of the early stages of 3D development. So back in, stating my age here a little bit, back 2009 when 3D was barely coming out, virtual reality, augmented reality was a little bit, I don't know, what's that, Oculus? Now you say Oculus, people know what that is. Back then it was like an octopus. What's happening here? So, we engaged into those technologies. We actually were able to do a very innovative solution for the U.S. Army, where we actually were featured in the Discovery Channel, believe it or not.
Oh, wow.
And we got that company's CEO and the president to show up on site here in El Paso. Now you're thinking, why would someone who runs a company that's billions of dollars worth in revenue come to El Paso? The fact that he came over to look at something that just a few of us put together, me being one of the big collaborators in that effort as well. It's very humbling to me to know that came across. Shortly, I think after like 6 years, I departed that place because I had a lot of responsibilities by then, a lot of meetings, a lot of traveling, a lot of projects, and I worked a lot. So I wanted a fresh air, and I did what most developers, most software engineers like to do. That's changing career path. What I mean by that, I went from 3D simulation, game development, training aspect, into web development. Entirely a different story, different animal.
So you changed gears completely.
It's a brand new from scratch.
It's a brand new thing, yeah.
Yeah, and I landed at the a local location where it's like an intelligence center.
Here in El Paso.
Here in El Paso, yeah. This location was almost like a hub to other agencies. Mm-hmm. So it hosted a couple of applications that were running from the 80s or something like that, for example, and they need a revamp. Let's rework this. It had a couple of issues, and first day on board, I came up with a solution. 4 months later, Employee of the Month, go figure. Mm-hmm. I think it was a total of 5 applications that I managed to deploy in that location, and they're still running, which is a very good feeling after, I was there for another 6 years, and then it's been already 2 or 3 years that I left that place, and my understanding is everything's still good. That's a good feeling. Then, I went into what is known as private sector, right, with a startup. Yeah. Mobile device management, very simple. Nice little application to manage deployment of APKs, or what's known as the Android applications, and learned a lot along the way. Also got engaged at the stock market. There's a couple of things that I learned in there as well, not just in the venue of investing, but also in software. And Christian, there's a lot of flavors of coding, mm-hmm. A lot of patterns, a lot of design solutions that one team might be benefiting from versus one the other. So I felt that hopping around different companies really helped me structure into best practices, do's and don'ts, and overall a understanding that without a structure to deploy, continuous integration, continuous deployment, which is what we're going to talk about in the pipeline in the pipeline conference,
in the workshop.
In the workshop, yeah. So that pretty much is a standard in every single company. There's got to be a real good way to deploy that code that everybody's collaborating without risks, without breaking, without damages.
It's incredible you being bouncing from one point to another point, and holistically you start to recognize how the software, how the programs, what the patterns, and everything be working for the past decade, for example.
Yeah, it's been a while.
It's been a decade. That's just,
almost 15 years.
It's all, yeah, probably a little bit more. I don't know why I said just decades, just for the sake of simplicity. But it's very interesting because we were talking before the interview. Is that I remember when I was at UTEP as a student and then as an instructor, I remember software engineering was a highlight. I'm talking about early 2000s. Mm-hmm. And I was discussing with Cesar that there is a couple of transformations depending on the generation that you're living in. Mm-hmm. I always like to see, and this is not me, with conversation with other of my colleagues, we see that computer science is the main pillar of everything. But if you reintegrate computer science through time, you ended up with something called software engineering. Because you have all this coding, you have all these patterns, things like that, and you put it together and you develop software. But now it's not just any software. There's stages, there's principles, there's a rigor, and there's a science behind that. That's why institutions like UTEP, they provide a master's in software engineering. But software engineering now is being so popular that now we have so much software out there. Even from, you mentioned mobile apps, and
there's everything.
There's everything there. And now we're emerging to this new paradigm called DevOps.
DevOps, that is correct. And I couldn't have stated better. It's enormous, the different themes that you could take over. And I call them themes, augmented reality. You could even do something as simple as UI, UX, development, researching. Like, it still needs to have its own little standards, right? And I don't mean to minimize that effort. It's still pretty difficult to work in the front end experience here. But still, one of the biggest concepts in DevOps is the security. There's another one called DevSecOps, which incorporates a little bit more emphasis on security. What do I mean by that? Very simple. For example, like you're deploying a little project, a little Hello World application, kicks off in the pipeline. The pipeline is pretty much this stream concept where it guarantees that every single stage is met in a process, that before it goes to the next one, everything that needed to be passed and guaranteed to be working 100% is on that earlier stage, otherwise it moves on. So by the time it gets to the end, you have almost a guaranteed deployment that will not fail. Now, you might notice that YouTube and a couple other big websites, they just change. You refresh the page, it's got an update. Facebook, this changed. It wasn't like this, what's new? You never seen, by the way, guys, Facebook is down for a moment because we're pushing the changes.
Right, we don't.
That went out the window. As you talked about generations, I happen to see that generation before me at the last stages when, machine learning and all that, I don't want to call it ancient technology, but like the foundation of development software, right? I got to experience some of those languages, and then how things used to be done. Books, you go to the book, you get it. Now, you Google it. You just Google yourself a solution, and we were talking about this, how GitHub now has that integrated system where you can just say, hey, I'm looking for a little method, a function here that is going to give me a sorted list, or that's going to remove whatever criteria you want to do, and it actually generates the code. And I think that is amazing. I think that is innovative. And then I suddenly realized, it's similar to a hammer. You can do a lot of things with a hammer, right? But making that hammer, that tool that can help you develop things, is one thing. But if you make it bigger, now you have a jackhammer or something bigger for other purposes. So my point is that tool will be more merged or forged into whatever solutions people need in all those fields.
So you mentioned GitHub, right? GitHub is basically a repository, right? It's a repository when there's a lot of software that lives there. GitHub, basically, you have the ability to go and post as a user, as a programmer, and let that software live there for the community. But not only that, the community can go there, it's like, this is interesting. I'm going to amplify that, or I'm going to extend a little bit more by providing more things.
Yes.
So it's a community, right? Yep. So GitHub is It's like it's free. What is that?
It's a platform where, as you mentioned, developers go in there. Anything from new people, new developers, to people who are just interested. You can just how to sort an array, and you'll get there. You don't have to have an account or anything. It's open. And the good thing about that, it's a collaborative effort in the community that brings up interesting concepts. Since there's many ways to code. I still think, I don't know who mentioned it, it's been said a lot of times, coding is an art, and everybody can do art differently. There's no right way to code, but there are things that you should avoid sometimes, and GitHub tries to eliminate those bad ways.
Very interesting. As a matter of fact, because we've been developing, and you mentioned something very interesting about the whole generation aspect. I remember when I was a software engineer, when I became a software engineer, we didn't have, Google was there, not with the ability that nowadays you Google stuff and you get in nanoseconds responses immediately. Now, communications are becoming super fast. Now there's a lot of accessibility, blogs, Wikipedia, there's a lot of resources, okay? So back in the day, I remember there was nothing like that. We used to go to the book and we start to put our efforts to create a software, to create a piece of code that worked for X, Y, and Z without the security involved, by the way. We just wanted to make it fly, and that's it. Now, you mentioned GitHub. We've been programming for the past almost 2 decades, and there's enough information. And this information that you mentioned called GitHub Copilot. It's an artificial intelligence. I think I was impressed. When I first saw this, you just put a piece of code. For those who don't know, when you start coding, there's too much code that there is very, very similar to other pieces of code. So what happened is that artificial intelligence mechanisms, they recognize these patterns. So they propose you an automatic definition of this code, right? Which for me was amazing and scary. As an educator, for me, is like, wait, that's the question.
That was the
from
homework
test
assignment.
number 3.
Yeah.
How you just get it in seconds automatically. So hopefully my students don't, okay, this is a crazy question, but hopefully they watching this show, hopefully they don't watch this segment, because as you just type a code, you put it and just pull all that information from the web to say like, this is what you want, right? Now, you mentioned previously about DevOps that you can encapsulate pieces of code for a reason. Can you please elaborate a little bit more why you encapsulate?
Of course.
Yeah.
For example, sometimes you're writing your own code, like you've probably seen it, your students, they send you code that they claim that it worked on their machine. It
all
worked.
the time.
It used to be there, like I said, it was working.
Yeah.
I don't know why. What error you got? I've never seen that error. Encapsulating that work, that piece of work, into an image and then later deploying it into a container guarantees that when someone else gets that image or that recipe of that code, it will behave and be exactly what you intended it to be, with the test scripts included and everything ready to go. Now, why is this key? Because there's that magic word again. There's that confidence. There's that trust in others. You know, that when you have code that, as we were mentioning in our conversations, that could generate millions of dollars in damage.
Yeah.
You don't want your name to be behind that the link right there, right? Or even worse, where lives depend on it. If you are on the medical field, you want to make sure that that variable, that value that it's supposed to represent, it's exactly what it is. I think there was an issue once where a plane miscalculated the altitude, right? And it just went tumbling down harder than it should have. And I think it was just a couple of thousands of dollars of damage, several hundreds, I'm assuming. Probably lawsuits, millions, I don't know. But I don't know if anybody died, but if they could have died, that's when the magic happens. You don't want that to happen. So same thing with space shuttles. I think there's a reason why they don't do them all the time, because they want to make sure that before they do one, everything's been tested and sound to go right. So yeah, that's pretty much the concept of encapsulating your code.
So you mentioned something very important, because this has happened in the past. I mean, as a software engineer, you pay attention on this kind of news. But for example, in previous situation, including the Apollos from NASA, there was one particular Apollo that the conversions, they were not properly done, One was in meters, one was one in feet, and then unfortunately was some lives that took that thing. As a software engineer, because you're a software engineer by training, but you have done a lot of different aspects, holistically speaking, that are around software engineering. As a computer scientist, you're a problem solver, you're a very good problem solver, but you've been connecting things. Tell me your experience as that aspect that you just mentioned about lives, because we have responsibilities. People say like, oh, I'm gonna be a hacker, I'm gonna put something, get into some bridging, then get some caching, I'm a hacker. Right. But technology is not only about hacking and things like that. When you are a software engineer, you have other kind of responsibilities, because you're the responsible of creating software, medical software. You're the responsible to develop the cars. There are actually the autonomous cars, right? Or when you have some kind of recognition of items. Can you tell us a little bit more and how that fits in the conversation?
Yeah, so as you mentioned, the holistic approach, right? There's more to just, get this piece of code written in there so it does that behavior that you're expecting. But you got to make sure that follows standards or requirements that someone put together, right? The whole purpose, the mission of that code always has to be backed by some purpose of your coding. Otherwise, you're just wasting your time.
Yeah.
So that's when a multidisciplinary team comes into play. You need to have the database guy, you need to have your sysadmin to make sure that your servers are up and running with correct privileges so that you can actually deploy your code. You need the DevSecOps or the DevOps process puts all of those disciplines together and ensures that it all handles correctly. In my experience, post DevOps, pre-DevOps actually, I would see a lot of issues. When you would say like, okay, this code's ready, let's deploy it, but you can't just deploy whenever you want, because some user is on the other line using that system that a life's depending on it. So you have to wait on it. So now you have a whole team of let's put it like a call center, where that their purpose is to facilitate the use for law enforcement to take action or something. You can't just bring everybody down because one's waiting on it. But it was horrible, because sometimes we did up to 20 minutes while that last call was being processed. Time and money is being wasted because you're paying all those people waiting for you to bring down the server, to bring it back up. And what if it fails? You got to be able to respond to it and revert and put the other one back in.
You mentioned something about many companies, they say when your server goes down, you're missing thousands of dollars per minute. Yeah, and when you deploy, I think the word here that you use, deploy, is unique, especially in the DevOps. By the way, DevOps stands for what? Development
and operations.
Operations. So when you have your mind DevOps, you say like there's certain operations in the whole process of the development. There's a pipeline, yeah, and each pipeline has those checkpoints.
In the stages.
And this is a beautiful concept that you introduced. Gilbert talked about that last conversation, and probably next conversation we will talk about a little bit more in depth. But each checkpoint has a level of trust or confidence.
It's intention, it's purpose. In stage 2, for example, you got to make sure that all the test scripts run. And you borrow a tool like Selenium or something that's automated for the front end, or even just run the test scripts on the back end. And they all have assertions to make sure that this, when called, should give you this. And lights go green, moving on to the next step.
Gotcha. So you have like a semaphore or like a light that you go, like you cannot pass from point A to point C without passing to point B.
Oh, it's beautiful. You see the stages, they go green and red.
It's a beautiful concept because as a user, you trust certain software, you trust certain apps, and sometimes you don't trust them at all. But as a software engineer, you need to know what a trust is and a level of certainty for each of those stages. For me, it's a beautiful concept that you brought, because as a software engineer, a 1 is a 1, a 0 is a 0, and there's nothing in between. Of course, there's a lot of things between, but when you execute that program, you need to have 100% accuracy that you know is going to be deployed effectively.
It is or it isn't, that's correct.
And I think that helps a lot, because one of the areas of research is trying to define the concept of trust. It's not easy.
No.
I mean, I trust you at some level.
Yeah, there's
you're my friend and
yeah,
things
there's
like
always
that.
much, yeah.
But Cesar might be, I don't know, I trust Cesar 98.9%. How do you trust a software? How do you trust computing in general? And in people you may or may not trust them, but as a software engineer, you need to trust that certain components going to deploy with 100% of accuracy.
That is very true. And yeah, like as I mentioned, I've been in multiple development teams now with very, very smart individuals with master's degree, with doctor's degree. I don't have a master's degree, I'll put that out there, but my experience has put me up to pair with those who do, and I think that's something that I always bring to the table. I've seen this before, and it works this way. You know, life personally took me to being a father before being able to jump to a master's,
Right.
Follow my master's degree. But at the same time, it was a great experience. Now my daughter's like 12. Hi, Vani, if you're there.
Congratulations.
Yeah, so it was interesting to see all that explode within a couple of years, you know. But overall, the main concept of our workshop next week is to focus on that capability of what is available, a tool that is available, and also a career path for many, because not everything is about writing for loops or anything like that. As you see in the intro levels, right? It could be as simple as configuration, and that's what DevOps mainly focuses on. It's a holistic approach of development.
I think you brought many different concepts, and I'm very happy to have you here. I think you mentioned something very critical, that PhDs are important. I'm a great advocate for education. I want everybody to get a PhD, but the experience, when you saw this holistically, when you see these different parameters as an expert, I think that's what makes a software developer that you are, the caliber that you are, that's successful. I want to thank you for joining us today in the Hackers Corner. I'm looking forward for you guys' workshop the next week. We are very happy to receive the feedback from all of you. Follow the Hack the Border, too many hackings nowadays. hacktheborder.org, which is the binational effort that we're doing right now for the border good. We're very happy and thrilled to have all this input and the colleagues and partnerships that we have established for the past years in order and in up and running like a software development deployment. My name is Servín. It was great to see you all. I hope everybody's doing well, safe, and healthy. I'll see you next time. Happy coding. See you next time.